Second one is the air jacket. After that, there is a copper calorimeter. There is a container. This is the copper calorimeter. This copper calorimeter has there is a Beckman thermometer, which accuracy, that means least count is 0.01 degree centigrade. And after that, there is a stainless steel bomb. In that stainless steel bomb, there is a stainless steel crucible. Okay, in this stainless steel crucible, we are having the fuel sample. Suppose you are going to take here the coal, whatever may be. Here you are going to take sample of the fuel. And this crucible is attached to two electrodes connected with the 6-volt battery, DC battery. And this is the MG wire. MG wire, the role of the MG wire is to connect the two electrodes. And there is a magnetic stirrer. What is the role of the magnetic stirrer? It provides the uniform temperature. It provides the uniform temperature. Now we are going to discuss the construction of the bomb calorimeter. Construction of the bomb calorimeter. So first of all, we are going to discuss the construction. Means what are the different components of the copper bomb means a bomb calorimeter. So first one we are going to discuss the bomb. What is this? This is the stainless steel crucible. Stainless steel container that in which there is a combustion of the fuel. The combustion of the fuel taking place inside the bomb. Okay? It contains stainless steel crucible which is connected with the two electrodes, and that two electrodes connected with the 6-volt DC battery. The crucible is attached with the magnesium wire. There is also the oxygen valve over here in this lid, and that provides the sufficient amount of the oxygen for the burning of the fuel taken in the crucible. Okay. Second point, calorimeter. It is the copper calorimeter, copper container, which is filled with the water in such a way that stainless steel bomb is immersed. Okay. This copper container contains a special type of thermometer known as Beckman thermometer, which records the initial and final temperature of the water inside the copper calorimeter. It is also contained a electrically operated stirrer which provide the uniform temperature in the copper calorimeter. Copper calorimeter, okay. Third point is the firing unit. Firing unit, that means it's connected with two electrodes. The electrode connected with the 6-volt DC battery, which will help to combustion of the fuel. Okay. Now, what are the working of bomb calorimeter? First of all, we are going to take the calculated amount of the fuel sample inside the crucible. That crucible is connected with two electrodes. That electrode is connected with the 6-volt DC battery. In this crucible also we are having the 10 ml of the water sample. In the presence of the sufficient amount of the oxygen, when you are going to connect the fuse wire of the DC volt battery, there within the limit of the time, it is start burning. There is a combustion of the fuel. Okay, switch off the power, and with the help of the Beckman thermometer, you can measure the initial and final temperature of the water containing in the calorimeter, copper calorimeter. Okay. Now, observation. Observation and calculation. Under calculation, we are going to discuss. Suppose we have taken X gram of fuel sample. Let X gram of fuel taken in crucible. Capital W gram of the water sample taken in calorimeter. Small w is the water equivalent of calorimeter. Initial temperature of water suppose this is the T1 degree centigrade. Final temperature of water T2 degree centigrade. How did it? These are the observations. Suppose Q is the calorific value of the fuel. Q is the gross calorific value of fuel. How much quantity of the fuel you have taken? X grams. Then total heat liberated. If the gross calorific value of the fuel is Q and you have taken the X gram of the fuel, how much quantity of the fuel generated? X into Q. So heat liberated after combustion of fuel is equal to X into Q calorie per gram. And this heat, liberated heat, is absorbed by the water containing in the calorimeter. So, what is the rule? What is the law? Heat liberated heat equals to heat absorbed. So, here, according to the law of heat transfer, that is the heat liberated is equal to heat absorbed. So heat liberated Q into X and heat absorbed. Heat absorbed by the water as well as heat absorbed by the water equivalent of calorimeter. What are the water equivalent of the calorimeter? Except water, the system which is inside the calorimeter is under the water equivalent of the calorimeter. And now, what is the formula? What is the formula for calculation? You know, Q is equal to MC into delta